You are not audible, Pawan sir.
Am I audible?
Yes, sir. Perfectly audible, sir.
Oh, okay. Dr. Khan, are you there?
Yes,
Yes.
Okay, now I request my colleague, Dr. Sohail Ahmed Khan, sir, to introduce Dr. Partha Sarthi Banerjee. Please, sir.
Good morning to all. This is Dr. Sohail Ahmed Khan, Department of Computer Science, Indira Gandhi National Tribal University, Amarkantak. It is an honor and privilege to welcome all the students of our subject and our subject expert for this today's session, Dr. Partha Sarthi Banerjee. Here's a brief introduction for our subject expert. Dr. Partha Sarthi Banerjee had his BE and MTech degree in Computer Science and Engineering, both from Birla Institute of Technology, Misra, Ranchi. He was also a research fellow for the PhD in Computer Science and Engineering under the prestigious Visvesvaraya PhD Fellowship of Ministry of Electronics and Information Technology, MEITY, Government of India, being implemented by Digital India Corporation at National Institute of Technology, Durgapur, West Bengal. He started his career with Unit Trust of India Technology Services Limited, currently UTI Infrastructure Technology and Service Limited, Government of India, Mumbai. After industry experience, he decided to serve in academics and hence he joined the Department of Computer Science and Engineering at JP University of Engineering and Technology, Madhya Pradesh, a part of the JP Group, India. He is working in the field of natural language processing, unstructured data handling using machine learning. His area of interest include natural language processing, unstructured data handling using NLP and ML. He has designed natural language information interpretation and representation system NLIIRS for MEITY, Government of India. Publications we can access through online. His affiliation with professional bodies include Life Member of Computer Society of India, Life Member of the Institution of Engineers India, Corporate Life Member of the Institution of Electronics and Telecommunication Engineers, Life Member of Indian Science Congress Association. Sir, welcome to this program.
Thank you. Thank you so much, sir. Thank you so much. Share screen.
Thank you, Khan, sir.
Is my screen visible now?
No, sir.
Just a moment. Just a moment. Share content. Slide access here. Is it visible now, sir?
No, sir.
Actually, my on my mobile phone it is open now, but I don't know why I am not able to. I'm going to the share content, right? Then I'm going to share screen. I'm sharing the screen. It is saying WebEx would like to access your alert window to make it possible to share your screen in the meetings. I'm doing
Yes.
an okay.
You may try, sir. If you're facing any type of problem, then you may share your slide to us. We will share from here.
Just a moment, sir. Just a
At your end,
moment.
but if you are facing any error, okay, no issue, sir.
Just a moment, sir. Just a moment. Just a moment. I'll wrap up everything and whatever. Okay, I'm just sending you my slides, sir. Am I audible, sir?
You are audible, sir. Please send to me or mail to me. Okay.
I'm just sending it to you. I'm just
Please,
mailing it to you
please.
under CS_workshop at IGNTU.ac.in. I'm sending in this. I guess.
Now it is visible, sir.
I guess now. Thank you so much. Thank you so much. And I'm really, really sorry that I took up some time from you, those who are listening to me. Okay, shall we start with our presentation, sir? Dr. Rathod, sir,
Yes,
shall we
sir.
begin?
You will start. You will start, sir.
Okay. Thank you so very much. Thank you so very much. Okay, once again, I'm so sorry to all of you, but I'll try my best so that you can get some of the better glimpses of the work done at some of the finest institutions in India. And I'll be sharing some of our work in the area of actual applied machine learning in the area of natural language processing, or in fact, unstructured text to structured data conversions. Okay, so as you can see from the initial introduction slide, I hope the things are a little smaller, but I'll try my best so that, no, you can see it nicely, right? The introduction part, can you see each one of you? Can you see it? Can I get a response from your side?
Yes, sir.
After zooming, we can see.
Okay, fine. So let us begin with some of the very important insights into our work of today. Basically, whenever we have talked about structured and unstructured data, I'll be just narrating you some of the stories, and I'll be giving you some of the mathematical deductions of how we actually implement the work that I'll be first explaining it to you. Then I'll be showing you how we have implemented it. Okay, fine. Now, let's begin with something called as structured information and unstructured information. If we talk about that structured and unstructured information, then I'll straight away take you to this slide, that the slide that is in front of you. We generally categorize our data. I'll take you through a smoother transition from structuring of the information to natural language to application of ML in these areas. So our flow will be in a tri-directional manner. So kindly try to put your attention. You'll be able to understand it. So if we talk about the structured information, we'll be basically talking about the data that is having a defined model, or in fact, it is in some kind of format, right? In some kind of format. Now, formatted information or structured information has been in utilization for quite a number of years. Let's say from the beginning of the mid-1990s till 2010, or in fact 12, we had a huge amount of structured information. Now, if we talk about the structured information, then obviously we need to know that what is a semi-structured information. That means little bit structured, little bit unstructured. Now, your question would have been, why are you taking us towards a semi-structured information when we are already having a structured set? Now, let me tell you that if we talk about the practical aspect of a structured format of a data, then we'll be calling it as a DBMS, database management system, right? We are having the structured set of information in the form of tuples, relational tables, schema, and OLTP. All these formats that we see are very, very concise, formatted, and well presented set of information. But over the years, as we have seen that the boom of information has occurred, we found the necessity of having something that is semi-structured or in fact quasi-structured. Now, if we talk about the semi-structured, that means we talk about the textual data files with an apparent pattern, right? We are having certain homogeneous type of file sets that are having a pattern. Now, gradually, even this thing lost its charm over the years. Reason being, when we search a content in Google, we generally get, let's say, if I'm asking you that at Amarkantak, what are the places to have the best Bengali sweets out there? Will someone be providing me with a beautiful RDBMS table stating that this is serial number 1, serial number 2 for the first sweet shop, the second sweet shop, or even further? Will I be getting the information in this manner? And then the rate of the sweets for every shop is provided in a beautiful structured format? No. Actually, we'll be getting some of the blogs, or in fact, some of the URLs that will be catched, catched on the basis of my index searches that I'll be putting up in my Google search. So that means that the information that I'll be getting for my query, that means the sweet shops at Amarkantak, will be in the form of a textual information or a text heavy information. Text, by the term text heavy information, what I mean is that we are having the text in the form of natural language information, right? In the form of natural language text or information. That means a lot of sentences will be written, a blog about the best sweet shops at Amarkantak or the best sweet shop in Madhya Pradesh. Then some of the information is related to Amarkantak, because that is also one of the index valued words in that searches. We'll be getting all those data. Now, to draw your attention, can I even call this kind of information as a highly unstructured information? The answer would be yes, I can call it. Yes, I can call it as an unstructured set of information. That means the data that has no inherent structure and is usually stored in various different types of file formats. Like you can have the data in the form of PDFs, images, videos. That means I can say that it's a heterogeneous kind of data or the information that I'll be getting. So in today's day world, or in the today's day of information age, the information that we get are around 88% of the information that we are getting according to the Forbes 2021 rating are in the form of unstructured data or unstructured information. Now the question arises is that why is such a big fuss about unstructured data, or so-called, we call it as the data sciences or handling of the natural language information? Why is such a big fuss there? At this point of time, I'd like to take you towards the slide that is right at the middle of your screen. Many of us have got certain amount of idea about the Google Assistant, right? You just click on the mid button of your handheld device, that means your phone, and instantly you get an assistant that is the OK Google format, and you just speak out OK Google, and you get a hell lot of information. That means you just speak it out, and you start getting the flow of information in any particular dimension of your choice. Likewise, in case of iOS devices, like you will be getting Apple Siri, or you can even have in the crudest of the forms like Alexa or Google Mini, where you just narrate the name of a song and it starts playing. I'll not straight away go to the application of these unstructured information searches from the Indian perspective. But before that, I would also like to draw your attention towards one of the finest innovations of the century, whose presentation was given by our Mr. Sundar Pichai, the CEO of Google. It was about Google Duplex. Many of you might have heard about this Google Duplex. Google Duplex is a highly innovative AI-based structure that is based on machine learning as well as natural language understanding. That means when your phone starts taking charge of the whole of the device and makes out calls, books assignments, and does all sorts of work that can be done by you with all the finite and the minute nuances. Nuances in the sense that when you give a call for booking up a table in a restaurant, you say, Acha, can we book out a table for 4 people? They'll be saying, no, you cannot. You can have a minimum of 10 people. And you say, no, I don't have 10 people. I'm just having 4. Can we just minimize the cost? So you are having the cognitive ability to understand the minute information set that has been provided to you in the form of unstructured information, that means in the form of natural language text narrated or orated by an individual. Fine, this is a very complex process which involves the latest techniques of natural language understanding and machine learning processes. But do we have these kind of advancements in our country? That means in India? Yes, we do have it. Yes, we do have it. And in many of the day-to-day applications, you do use it. Like many of you have even seen, while booking your ticket on the Indian Railways, you have seen Ask Disha. Or while going through SBI, you might have also seen Ella, Ask Ella. Now, what are these? These are basically, we call, as many of the commoners, they call it as a chatbot. A chatbot. Is it actually a chatbot which does a kind of conversation between you and the machine, which creates a kind of coherence between the user and the machine? No, actually not. It gives you the information. Like if you go to the IRCTC, you click on Disha, and the moment you'll be typing a train's number, it will be giving you the train's departure, the whole route, the availability of the seats. These are the information that will be given to you. Now, in our prior perspective, before we would have gone for the application of the machine learning processes like hidden Markov model for processing of unstructured information, or in fact linear regression types or naive-based applications, what you would have done, you would have fired an SQL query to extract the information from all the relational tables available with the IRCTC, right? This thing you would have done. But I'm not mocking our systems or our technological advancements, but many of you, those who use this IRCTC portal or SBI or PNBs or various other tech financial tech financial softwares or tech day-to-day usability softwares, you will be finding that they work horribly. They're miserable. If you are typing for an FD, like I want to procure an FD for an amount of 10,000 in Ella, you'll be getting a horrendous or a very different sort of information. And at the end, they will be writing down a statement that our bot is still learning. Thanks for the information given. That means right now, the user is not actually the end user. You are basically a trainer for their system. You are giving the informations to them. You are providing them with the set of training for their actual chatbot, which is under the machine learning paradigm, which is going on, still going on. So how to deal with these kind of situations in a complex data handling environment involving natural language understanding, and how we can introduce machine learning in these areas so that we can handle these difficulties. So let us now move towards a little motivation. Many of you might have heard about a gaming platform called as, earlier in until 2010, 12, it was very popular. Now, it was basically called as Jeopardy, the game of Jeopardy. And it was first time played by it's a very popular game back in the United States. What happens in Jeopardy is that they give you some set of prior information. So you can have some cues. That means you can keep some information retained within you. Like you can keep some books, or you can read a hell lot of information. Like if I say that I'll be conducting a Jeopardy. Jeopardy means a Q&A session, a question and answering session. I'll be asking you some questions from medical domain. You have to say who's the first surgeon who has conducted the surgery in India or in Southeast Asia. So you can go through all sorts of medical books for 3 days. Then you come to the Q&A session and we'll be firing up the questions, and you have to give a reply to that, for which you'll be paid. For the first time in 2011, IBM Watson played the game with human beings and it won the game comprehensively. Now, what does this thing proves? This thing proves that while extracting information by using Q&A, why I have introduced the term Q&A? The introduction of the term Q&A is like question and answering. Earlier, what we used to do, we used to write out SQL queries to extract information. Now we are not doing it, even though we do it at the back end for some point of time, but majority of the shift of information extraction for data sciences has gone to Q&A, question and answer. Now, what is this Q&A? Can you train each and every individual to write out a script to extract information, write out a small piece of program or an SQL query to extract information? It's absolutely not acceptable in a country like that of ours. So what we do here is we rely on human cognizance. Okay, fine. You are an individual. You write your question in the way you want to write. Write it in a natural language. Now here, our default natural language is English. Many of you might have asked or might be asking, like, why don't we go for Hindi? Yes, a lot of work is going on for Hindi. A lot of work is going on for Bengali and other regional languages too. But at present, since we are dependent on the European Union as well as with Central American countries, for our business, we try to tend towards development of the software infrastructure on the basis of a default language called as English, right? So now what is happening here? Now we are basically focusing towards English as a language. Now, what all things are happening here? Now, let's say in our case, if we talk about that we want to extract an information by firing a Q&A, that means by firing a question and expecting an answer, Q&A, then what will happen? Now, we can fire questions like, who founded Virgin Airlines, or who's the founder of Apple computers, right? Now, here, one more thing needs to be answered. Like, since you are firing a question in natural language, that means from a source, you want to extract information, then what should be the source? Here, in this case, your source can never be a structured information. If you're getting a structured information, that's well and good. That's well and good. If you're getting the information in the form of a structured table, an RDBMS table, it's fantastic. It's well and good. Why it is well and good? Now, in this case, you will be having a hybrid model. You'll be having a hybrid model. Hybrid model means you are having a structured information and you are putting up a query in natural language to extract the information from that structured information. So what you got to do is you have to convert that query in natural language to a SQL query and then fire it from the table. This is one of the processes, right? Now, if I say that nobody is going to read through the whole of the Wikipedia page on Virgin Airlines and come up with a table, develop a table for me from which I can extract an information, that is somewhat very, very tedious. I cannot expect it, right? So what I can do here is that I can have a PDF file or I can have a text-heavy set of information, TEXT text-heavy set of information, which will be carrying all the information related to Virgin Airlines or for all the computer companies of the world like Apple, or you can go through the IBM computers, all sorts of informations are there, and you can fire a query on that, right? So this is, I'm just giving you the introductory part of it. Now, if you're having this type of, ab maine aapko kahan se kahan shift karwaya na, you have now shifted from simply writing down an SQL query and getting an information to writing a query in natural language. That means asking a question in natural language and getting a reply in the form of structured information. Your question could have been, what do you mean by getting an answer in the form of structured format? Now, getting an answer in the form of structured format means something. Now, what does it mean? Let's come down to that means. In front of you, you are having a slide that talks about this information. Now, let me tell you what that structured information is. First of all, for all of you, those who are new into the area of data sciences, you might be knowing that when we fire up a query in natural language, we are generally dependent with the WH category words. What, when, these kind of things. What, when, which, WH category words. WH category words, WH category words that basically gives us a question forming sentence. A question forming sentence means, what is the color of Ram's shirt? Who found out Apple computers, right? So these are WH category words that makes us form a questionnaire sentence. Questionnaire sentence means a sentence that is of question. well and good. Now, if the query that is to be fired is in the form of questionnaire, then what is the next thing that I'll be expecting? The next thing that I'll be expecting is an answer from the unstructured information, right? An answer from the unstructured information. Now, we are human beings. We are capable of giving answers with cognitive abilities. Cognitive abilities means if I ask that who's going to win the UP elections this time, many of you will go with a party A, or many of you will go with party B, and some of you will give some of the convincing replies that party A is going to win because they have done these kind of works in Uttar Pradesh, or party B is going to win because they have done some other different kind of works. Now, this is your comprehensive ability that gives you the power to reply to the questions by having pure human cognition. But can you expect it from the system? The answer is a big no. So how to inculcate it? Now, let us reduce down the answers in 3 different formats. What are these 3 different formats? Now, these 3 different formats are getting the answer in the form of either a factoid reply, or getting a non-factoid reply, or getting an opinionated reply, or sometimes the 4th format that I, or sometimes some of the Stanford machine learning group, they talk about is the narrative reply. Now, let me explain it to you. What are the 4 different types of information or the structured information extracted can be? Okay, factoid. What do I mean by factoid? Now, if the answer provided to you is in the form of facts, what do you call, or what do you mean? What do I mean by facts? Facts are like, if I say, from which direction sun rises, your answer would have been east, right? It's from east. Where does the sun sets? It's towards the west. So east or west, if you say only a single word to answer to a query, these type of answerings or information extracted is called as a factoid answering, F-A-C-T-O-I-D, factoid answering. Now, what happens when we go for a non-factoid answering? Remember that as a human, when you ask a question to another individual, that, okay, fine, would you like to have paneer today in the lunch? They'll be saying, yeah, I can have paneer, or I'm okay with no paneer also. That means they will not give you the answer in the form of yes or no. They will give you a few sentences, in fact, a few phrases. They'll be saying you, okay, fine, I can have paneer. No, I cannot have paneer. So these are small unstructured set of information जो बहुत ही which will be much more like human, right? Much more like human. So these kind of replies are called as the non-factoid replies, right? Non-factoid replies. And the question that corresponds to non-factoid questions, non-factoid answers are called as the non-factoid questions. Generally, they are of complex narrative questions. Just go narrative. I previously said that you can even have the narrative segment separately. You can have the narrative segment separately also. But instead of making it separate, you can keep it under the head of non-factoid questions only. Now, next one. So we have now dealt with 3 different types. We have dealt with the factoid. We have dealt with the non-factoid, which can also be clubbed up under the narrative questions. Or you can go on with simply with the non-factoid. And the last one is the opinionated questions. Now, what is opinionated question? Opinionated question is like, it is about decision-making questions. Now, decision-making questions are what? Like, if I say, who's going to win the next election? Should it be Joe Biden? Or it can be Donald Trump also. Now, some of you might say that Joe Biden did these kind of works and he may have a better idea about the United States of America. So he has got a better edge to win as compared in comparison to Donald Trump. Some of you may say, no, Donald Trump is going to win because he's a big businessman. Now, these opinionated based questions are some of the questions that humans reply in a much better manner. Why humans reply? Because they can assess information, right? They can assess information. They are trained. They are machine learned. They are machine learned to understand that how to justify your viewpoint while giving an answer to a query. But can we do it with the machines? Yes, with the present technologies, we can do it with the machines. We can seriously do it with the machines. Now, some of the paradigms that you can see here is like, in case of information extractions are like IR-based approaches, some of the finest IR-based, by the way, the term IR means information retrieval-based approaches. One of the approaches are Trek, IBM Watson, Google, that you can see. Now, knowledge-based or hybrid approaches can be IBM Watson, Apple Siri, Wolfram Alpha. Wolfram Alpha is another search engine. I hope many of you might be knowing it. It's basically for mathematical extraction of information. Now, you can have True Knowledge EVI and some of the other sources also. Now, while we are talking about the Q&A, we must also have an idea. Two technical terms are also involved. Like what kind of question and what kind of answers are involved in the Q&A for information extraction, for unstructured information processing. Now, the first one is the closed domain approach. The next one is the open domain approach. What do I mean by closed domain approach? Jeopardy is a great game that is a closed domain approach. Disha for IRCTC is a closed domain approach. ELA for SBI is a closed domain approach, whereas Google is a open domain approach. Now, what do I mean by closed domain approach? Where the data or the information is strictly restricted to one particular domain. Like if you want to create an AI-based system or a machine learned system which can reply to the questions, any sort of natural language questions over the FIFA World Cup. That means you can now capture all the information of FIFA World Cup and you can store it in the form of PDF files, and then you can fire a query in the form of natural language question, and you can extract information from them. So this is a closed domain one. That means you can only ask questions related to FIFA, that means football, and nothing else. Now, what about this open domain? Open domain means you are now not restricted to ask the question from a single domain. You can ask question from multiple different domains, anything and everything that is in your head. That means you can type anything on Google and you can put up a search click and you'll be getting the information, some sort of information related to the query that you have put up, right? Now, let us come down to the technicality or technical aspect of it. Let us start up with example number one. Well, I am not intended to give my generic viewpoint towards any individual whose preference for language is very stubborn. What I mean by this sentence is that I'm not saying that if you are knowing English to a greater extent, then only you can go on with the processing of the unstructured information in a much better way. You can go on with your own linguistics arena also. Like if you're good in Hindi, you can go on with your research in that area also. But in our case, by default, we have taken English as our particular area for research. Now, many of us, those who has a very keen interest in knowing the linguistics of English language, they might know that we generally use how many different categories of word that we use in our day-to-day activities or day-to-day oration abilities. We generally use 5 to 7 different varieties, like noun, verb, adverb, pronoun, participles, a few, right? But you'd be amazed to know that in actual English language, we are having 36 different types of word categories. Yes, you heard it right. It's 36 different types of word categories that you can find in the English language. Now, 36 different categories means 36 different types of indexes that you need to create for segregating the information in natural language. I'm gradually taking you towards now from unstructured information towards natural language only. Now, natural language is by default the best example of unstructured information. So 36 different types of indexes means 36 different types of parts of speech tags are required, right? Now, the question arises that shall I develop a system for all the 36 tags? Shall I go on with that? No, we should not. What is the reason behind it? Now, if you are developing an algorithm for dealing with all the 36 different POS tags, its growth function for every step will be multiplicative, and hence it will go beyond our control, right? At the present moment, definitely you can have much more better algorithms from your end, which can be much more efficient enough to deal with more than 10 or 12. Generally, most of the work that you're going to find in the natural language processing, you're going to see that people deal with 7, 8, or max 9 tags. That is what I have seen from Stanford. You can also visit their site. you can find that they generally deal with 5 to 7 or max 9 tags. So this is what you can basically do. Now, we're not going on with the application areas. I'll be talking about the application areas at the end, right? Some of the state-of-the-art works that you can see here is like the Terry Winogard's PhD thesis that is on Sherdlow. It's a procedure on representation of data in computer program way back in 1972. Then you've got a huge amount of work that has taken place, and then finally, at the present moment, you're gonna find some of the finest works in India being Tripti, Doria, Sonal Jain. It was back in the year 2016, and later on, a good amount of work that's taken place at our IIT Patna, then in IIT Durgapur, IIT Kharagpur, IIT Bombay. These are the pioneer areas where a very good amount of work in handling has taken place over the years in the last 4 or 5 years, right? Now, I'll be talking about the first work that you can see. Right? The first work that you can see. We call it as NIEQA. NIEQA is Natural Language Information Extraction by Q&A with an SQL interface. In very short, because I'm guilty of losing some amount of time, so I'll run a little faster. Like, first device would be not a totally unstructured information based, but a hybrid structure. That means SQL as well as unstructured information. We'll come down to the actual application of ML out here itself. Now, what is it basically here? If we talk about the previous works, you do have a past question, a resolve target references, then how to develop the questions based on it, and the projected top answers, and finally returning the exact answer that you can see on your slide at this present moment. In response to these kind of architectures, what we have done out here at NIT Durgapur in coordination with Ministry of Electronics and Information Technology, Government of India, here is the system architecture that you can see. Now, what does this system architecture do? Now, you are having initially an input corpus. That means an unstructured set of information. That unstructured set of information is fired with a query in natural language. And the answer that you'll be getting from here is a factoid answer. Now, what is the technique that has been involved here? Now, the technique that has been involved here is that the unstructured text X is first taken as an input, and X is annotated and then parsed against a pattern for classifying the test. Now, this pattern analysis is where we introduce the machine learning part, and I'll be talking about the mathematical implementation of it today itself. Now, if we talk about the first unstructured text X, then the text processing algorithm developed by us classifies the tags. Next, the text now completely delivers the final representation of the information extracted on which the questions are to be fired. Right. Now, let us see the algorithm to a certain extent. It's a very brief one. Actually, we are having around 3,400 lines of code for performing this whole action, and we are having around 11 algorithms associated with it, which is widely available online under the Mateys website as well as on Springer's headings. Still, like we have created KB1 and KB2, initially we have created KB. What is this KB1? KB1 is knowledge base 1 and knowledge base 2 to store the training as well as the test data. And the questions to store and QES is a queue to store the questions in NLTD form. NLTD means natural language text data, right? Now, if NLTD is available, then we start the process of segmentation, for which we do have a separate algorithm for it. And if the user asks a query, Q&A, and his choice wants to ask a question and his choice is yes, then we go for the Q&A part. And then we provide them with an answer. So it's a very crude and a simple algorithm, presumably, but the extended part of work is pretty complex. So let us see what is the technicality involved. Here, what we have done is we have used a predefined set of NER for our process. As I have said you that this whole process is basically based on a hybrid structure. So what we have done here is that we have used the Stanford's NER for our process. Now, what is this NER does? Now, NER, most of you know what is NER, named entity recognizer. Now, what does this named entity recognizer do in case of text annotation or information annotation is that now, the whole of the world's information as per the Stanford's natural language processing group is basically in the form of three categories. That is what they have said initially, way back in 2014-15. They said that it can be of three categories. What are those three categories? Now, those three categories are organization, location, and person. When the first initial concept of named entity recognizer came up. Now, what is this named entity recognizer? Means not all information that we do get can be clubbed under the category of 36 word tags that you have seen. That means noun, verb, pronoun, adjective, adverb, all these kind of things. It may have certain classified qualities. What are those classified qualities? Those classified qualities are like, we say that Maruti Omni is a car, right? You will not be calling it as a noun since the word Maruti is being used. You will not be calling it as a noun initially, other than the POSTEC application. You'll be calling it as a car, right? Now, this is what we know. We objectify the word Maruti because we know it's a car. You will be calling this Rolls-Royce as a car. You will not be calling it as an organization at that point of time. Right? So they said that the initial three things on the basis of which we can segregate the information is organization, location, and person. Then later on, they thought that no, this is not enough. What would happen to the remaining word class sets? What would happen to the remaining word class sets? Now, the remaining word class sets can be grouped up under one head. This was done very casually on part of Stanford, and they clubbed it up under the heading of MISC. MISC means miscellaneous. That means broad three categories remain the same as organization, location, and person, and the remaining all things have come under the category of miscellaneous. Ki baki sabko, you just club it up under the one head and keep it there. Then later on, they said, no, this thing cannot be done. Let's have some better ideas. So they came up with, now we'll be going on with a 7-class category. What are those 7 classes? Now, organization, location, date, money, person, percent, and time. So here I have put up an example for you. You can also check it out at your end by going through nlp.stanford.edu. They have machine learning extension processes. So you can go there, and this is a freeware that is widely available. You can just put your text there and you can get it annotated on the basis of their NER that has been provided by NLPG of Stanford. So you can see, I got a sentence there. Warner works for Microsoft in Texas since 2008 for $200, which is 20% of his previous salary. He wakes up at 6 p.m. in the morning. Now, this is excuse me. This is a very crude form of language, specifically designed so that we can have all the annotated texts out here, right? Why did we frame this sentence actually? This sentence is actually to club up all the 7 different categories so that they can be highlighted. So you can very easily see that Microsoft is being tagged as a organization, and Texas being tagged as a location, and 2008 being a date, and all the rest all tags are there in the form of color code that you can see here. This is a machine learning paradigm. We'll be talking about how these things are done. But initially, we have taken the pre-built API for our case. Now, what we actually did is, this is available. Now, when this is available, what they did is, they said that, okay, fine, we are done with the 7 class categories. Now, back here in our country, what we did is, we said, no, even 7 is not enough. So what we did is, we combined this class 7 category and class 3 category. In class 4 category. In class 4 category, we had a special tag called MISC, miscellaneous. What we did is, we involved our training set algorithm to introduce another, the 8th tag, and we called it as others, OTHERS, others. That means anything that Stanford defines as an organization will be organization, but for our Indian perspective, we can have others category also, and that others category is an extendable one. That means it's a machine trainable one. I'll be showing you how it is machine trainable. Now, before we go even further, let me talk about, I don't know how far it is visible. Can you see the table in front of you? Is it visible properly? Can you see it? Can you see the table? Dear audience, can you see it?
Yeah, we can see it, sir, but size, because
Okay, fine.
mobile, that is the issue.
Okay. Is it clear, or shall I just?
It is clear, sir.
Okay, fine. So as we have mentioned in our algorithm that we talked about KB1 and KB2. So our algorithm does the first work. What is this first work? Now, let's run in very short format. This part is like you picked up the first sentence with a delimiter. Delimiter is like a full stop. You picked up the first sentence, you segregated it, and you kept it in the form of a tuple in a RDBMS table, right? But what is happening is that we need to have the whole of the information, one sentence in one tuple, which is not possible. This is where you can see that they, in the first tuple, you can see they and rest all fields like person, determiner, activity, time, location, all are null. You can see all are null out here. So this was our KB1, knowledge-based one. The next part of the algorithm did another work. What is that work? Now we had the next table called as the KB2. In this KB2, what we did is we kept or we aligned the whole of the information of one sentence in one tuple. Whole of the part of one sentence in one tuple means, let's say if I am talking about Netherlands, Kalam lives in Netherlands. Kalam lived in Netherlands in 1996. That means it is a sentence which is having three important word cases like Kalam, 1996, and Netherlands. These are the three set of information to be kept. So these three information set has been kept in this table in one tuple. That means ID number 1. Likewise, the second sentence is kept in ID number 2, ID number 3, and henceforth. So if it is a 43 ID value, that means 43 sentences are there in our whole paragraph. You can have millions and millions of sentences which can be particularly broken down in the form of annotated tags with the modified NER that has been developed by us in the form of these 11 or 12 columns. Ask a question, can we have an extension of this column in the real time? Yes, we can have an extension of the column in the real time. That means if you are adding up this others or training or machine training this particular algorithm, you can have an extension of this particular column headers, right? Now, with some of the outputs that you can see here is like if the first text, now the smallest paragraph, what we can have in the smallest paragraph, now one sentence in a paragraph. So for our educational point of view, we are going through only one sentence at a time. Or in fact, in our case, the example that I'll be showing you here, you'll be having 4 sentences. So first text that will be processed is Kalam lives in Delhi. So what does our algorithm do? Now it is putting up Kalam lives in and Delhi as an annotated tag, and beside the tag you'll be finding Delhi as a location, and rest all are having, it's not a 0, it's an O value, O. The English alphabet O. O means others. Now what it does is the basic 7 entities location classification is what? Now Delhi comes under location, and for classifying the others, that means O category, it will be asking the user to train the system. It will be asking the user to train the system. So we are having a dual facility, whether the user, in first case, the user can also train the system. And in the second case, you can go on with a machine learning paradigm also. Immediately after this, I'll be showing you that also. So let's say the basic 7 entities, on the basis of Stanford's classification, Delhi is under the location head. And for others, what are the fields that are left? Now you can see as what entity do you want to place lives in which category you want to keep. So do you want to keep it in some category, 1 to continue or 0 to skip? We said 0. So the next word is token in. As to what entity do you want to place in which category you want to keep in. Now these are some of the words in the natural language information which doesn't carries any relevance. So under these cases, what you do is we just keep them. Sorry, I'm so sorry. We just keep them in none of the column headers. So we keep on skipping it. So now the information extracted is, you can see here, entity is location and the entity value is Delhi. Now the second entity is person and the entity value is Kalam. So now, since it is a hybrid structure, you fired a query, the system fires a query, that means alter table QANLIIRS and add location varchar 50 and person varchar 50, and the values added to the location as well as the person is Delhi and Kalam that you can see here. Likewise, we have processed the next sentence, that means Rashmi owns a purple car. Now, Rashmi has been put up under the category of O, owns O, A, O, purple is O, and car is also O. That means the Stanford's NER couldn't classify it. Even their machine learning paradigm couldn't classify it. So what we did here is we did a manual and a machine learned initiative from our part to classify it. What the system did next is the basic 7 categories under which it can be classified is token, Rashmi. As what entity do you want to place Rashmi in? This is what the system asks for. Now, if you skip it, the machine will pre-assign it, or else you have to keep it under one of the headings. So we have said, yes, one, we want to categorize it. Which category you want to categorize it? Now you can categorize it under the heading of C as what entity do you want to place Rashmi in? So that is person. We have said person. So now the next token is owns. As to what entity do you want to place owns in? We have said 0. We don't want to classify owns. Next one is A. We don't want to classify. Next one is purple. Yes, we want to classify it. We said it as color. You can see it at the base of this middle slide. 1, and below that we have written it as color. Now the total extracted information after this step is in front of you. Now you can see the entity is location and the value is Delhi. Entity is person. Value is Kalam. And in the CSV format, you'll be getting what? The Kalam as well as Rashmi is out here. The next one is entity color. And what is the value for the entity color? Now it is purple. Now the next entity is object. The object is car, right? Likewise, you do have further. Do you want to go on with further questioning? Sorry, this is how you have classified the data. Now you are going for the information extraction. Do you want to go for the Q&A on the given corpus? Y for yes and N for no. Yes, we want to have the question. So the question, please. Now the system asks a question like prompts you to ask a question. You asked a question, where does Kalam lives? This is your question or the user's question, in fact. What it does is it processes the question. And since I have said you it's a hybrid model, it converts the question into an SQL query. This is what the algorithm does. So where does Kalam lives has been converted into select location from QANL where person equal to Kalam and activity is lives. And then it is fired on my KB2, knowledge base 2 that I have shown you, right? From knowledge base 2, the answer comes as Delhi. Likewise, do you want to ask another question? Yes. Which color of car does Rashmi have? So now this question is again converted into an SQL query. Now select color from QANLIRS, that means the table name, where the object is equal to car and the person is equal to Rashmi, semicolon and enter. The moment you do it, you'll be getting the answer as purple. So this is how the initial few Q&A could be done on our system. Likewise, further Q&A can also be done. These are some of the more examples that you can see here. Now, while doing so, let us come to the more complex part of it. Let's say, Dr. Rathore, sir, respected sir, how much time do we have?
At 11:30, sir.
At 11:20, at 11:20, just a moment.
We have 15 minutes more.
We have 15 minutes more. Fine, fine. So here we have been talking about set A, set B, and set C. These are the 3 different data sets that we have used. Many of you know that in our exact computation of the output, we use the confusion matrix format for checking the true negative, true positive, false negative, false positive percentages. So these are some of the values, comparative values with the state of the art, right? These are some of the graphs that we have got for the set A, set B, the other set of information that we have fed. The 3 paragraphs that you have seen, which has already been pre-annotated or pre-trained, right? So these are some of the things. Now, we'll not go to the conclusion. Rather, we'll come to the conditional aspects of it. Why? Why basically we have taken the help of machine learning, which is a very, very closely associated aspect with natural language processing. Now, immediately after me, there's an esteemed professor from JNU who will be also talking about the application of machine learning or natural language processing. But before that, you can have certain more amount of idea in this area. So if we talk about the application of machine learning methods that we have implemented in this work can be subdivided under the head of supervised, semi-supervised, and unsupervised, even though we have gone for the reinforcement also at some other work that will be following. I don't know whether we'll be having any time or not. So let us see what we have done, what we have basically done, how you have got these beautiful beautiful replies for your queries. Now, the first thing that we have used here is the Engram model. We have used the Engram model. Now, Engram model is the machine learning application of naive-based, right? The naive-based approaches, best application is the Engram models. Now, here what happens is, if I want to check from the unstructured information, the probability of a sentence, I want to find out the probability of a sentence. So the probability of sentence can be precisely computed by the probability of the sequence of words occurring in it, right? Probability of the sequence of words occurring in it. So if I have to extract an information from an unstructured data set, I need to have the precise probability of each and every word in the whole of the corpus. What we use basically here, now we use the Markov assumption model that the probability of a word in a sentence depends on the probability of the word occurring just before it, right? Such a model is basically called as the first order Markov model. You can have the second order Markov model, you can have the hidden Markov model also for application, for machine learning applications, right? Now let us see what actually happens in the Engram model. Now in Engram model, if you're having a word WN, then its relevance, I'm using the word relevance, not the probability, even though the actual mathematical computation aspect is the probability only. WN depends on the word preceding it. In fact, all the words preceding it. So WN is dependent on W of n minus 1. So probability of Wn upon Wn minus 1 is probability of Wn minus 1 Wn upon probability of W of n minus 1, where Wn refers to the word token corresponding to the nth word in the sentence. So let us now see a bit more further. Like a combination of word forms a sentence. However, such a formation is meaningful only when the words are arranged in some order. Now, does the arrangement, that means the semantics of a sentence matters? Yes, it matters, but with the relevance to its machine learning model. Why I'm talking about this? Now, if I say sit, I, car, in the, even though all the words can form a semantically as well as syntactically correct sentence, but at this moment it is not. But still, if you ask for a particular example that can you have a sentence that is semantically as well as syntactically correct, but doesn't have a semantics associated with it, then what can be the answer to this query? The answer to this query is colorless green ideas sleep furiously. It's grammatically, that means syntactically correct statement, but it doesn't carry any semantics associated with it. So one easy way to handle such unacceptable sentences is by assigning probabilities to every string of words. That means how likely those words can appear in the sentence. For that, we do have the machine learning model. That means the probability of a sentence calculation. If we consider, let's say in a sentence, if we consider each word occurring in its correct location as an independent event, then the probability of the sentence can be given by probability of W1, W2, W3 until we reach for Wnth word in that particular sentence. Now, this thing can be calculated in which manner? Since it goes with the first order Markov model of machine learning algorithm, so by using chain rule, what we can have here? Now we can have here, kindly have a look to this expression, mathematical expression. Now P of W1, probability of word 1 multiplied by probability of word 1 multiplied by what? Now probability of word 1 divided by EOS, which by default we don't show it in the equations. EOS means end of sentence. That means delimiter, that means a full stop. So we don't have any probability computed for the EOS, right? But in some of the hidden Markov model, computations that will be showing you today itself, you can see it there also. Now, so for the first word, we are having probability of W1. For the second word, what we are having for the case of Markov first order model, now we can have the word and all its preceding words. For probability of W2, it will be probability of W2 upon W1. Likewise, for first order Markov model, what should be the probability of word number 3? The probability of word number 3 is probability of word number 3 upon W1 and W2. That means all the preceding words. Likewise, for the nth word, that means W of n, probability of W of n would be what? Now, probability of W of n upon W of 1, W of 2, W of 3, 4, 5, 6, up to W of n minus 1. This is our chain rule expression for first order Markov model for machine learning algorithm that we will be getting for computation of the calculation of the word probabilities in a sentence for each and every word, so that we can predict which sentence carries more value for information extraction for Q&A. Now, there is one more thing to be learned. Now, if I am having this expression, then for all the bigram models, you can see that you don't have to go through this whole part. I'll be explaining it to you in very short. Now, instead of putting up all the values in the denominator, that means if I am going for W2, I have to put W1 for W3, I have to put W1, W2 for W4, I have to put W1, W2, W3. So what is happening here is the probability sequence for the remaining words, that means the n-1th word in corresponding to the Wnth word, reduces the numerator's value. So instead of putting up such long denominators and going on for hefty calculations, we do have a hidden Markov model where we can simply conceal the remaining part of the denominator. So which part of the denominator will be required? Now here in this case, you can see here in this expression, now you can simply go on with the word and its preceding word, not the remaining all preceding words. So P of W2 upon W1, P of W3 upon W2, and P of Wn upon W of n-1. So we haven't computed all the preceding words in the denominators. So we use an EOS tag to mark the beginning and the end of the sentence. A bigram table for a given corpus can be calculated and used as a lookup table for calculating the probability of the sentences. Now let us see a sentence, one sentence from a corpus whose lookup table is in front of you. And from this, what can be deduced? Now, how we can deduce the bigram probability model by using hidden Markov, first order hidden Markov model to get the probability expressions for all the sentences that are available in that particular corpus. Here we are considering one sentence. That means I read a book and you read, and we are using the few words like you book a flight, I read. Right. So these are some of the words that are involved or frequently used word in the corpus. Now, how you are going to read out this particular lookup table? Now, this particular lookup table, we generally call it as the bigram table. So in front of you are having the bigram table. Kindly look at the columns. In the columns, you're going to find EOS. That means the end of sentence. EOS means end of sentence. So end of sentence for a sentence is what? The previous part of the sentence should also be considered as the end of the sentence, and the last part should also be considered as the end of the sentence. The previous part of the sentence's end of sentence part is the full stop for its preceding sentence, and the end of sentence for that particular sentence's ending is the preceding end of sentence for the next sentence. So आपको उतना सोचने की जरूरत नहीं, you just concentrate here. Now you are having end of sentence for the first set of information. After that, you are having you, then book, a flight, I read on the column part. Now, what we do here is by using the first order Markov model, that means the machine trainable model, we are getting the probability. Now, how we are getting it? Now, you have to look at the word and its corresponding word sequence in the horizontal part. So let us say that if I need to check the probability for the occurrence of the sentence, you read a book. You can see at the base of the table, there's a column, you read a book. So end of sentence is at the beginning of the sentence also, and the end of sentence is at the end of sentence also. That sentence is what? Now, you read a book. How do we calculate you read a book? Now, for every word in this sentence, you can have the Wnth word and the Wn-1th words probability. So let us see it out here. Now, P of U upon EOS. U upon EOS, why? Now, at the top of the bigram model table, the first column's first header is EOS, and beside that you can find U. So the first word in the sentence is you read a book. So you with end of sentence, where you gonna see the end of sentence? Now, it should be in the horizontal part. In the horizontal part, you can see EOS, and below that you can see U. So if you match these two, the intersection of U with EOS is what? Now 0.33. You can see from the lookup table. Second probability is read by you. Read upon probability of read for you is what? Now you have to go to the column where there is read written, and for you it is 0.5. So you have written down 0.05 0.33 and 0.5. 0.33 multiplied by 0.5. Now next word is what? Now next is A upon read. Why we have taken A upon read? Now the word preceding to A is read, word preceding to read is U, word preceding to book is A. That's why we are going in this manner. So read is, word preceding to A is read. So P of A upon read is what? Now go to A part in the column. We have gone to the A part in the column and read part in the column. The intersection is 0.5. So we have written down 0.33, 0.5 and 0.5. And finally, we are getting, not finally, the second last part is probability of book upon A. That means you have to go to the A part and then in the book part. So A part and the book part's intersection is again 0.5. So you have written down 0.5. So you are having 0.33 multiplied by 0.5, then 0.5, then 0.5, then 0.5. It is nothing but 0.020625 is what your bigram model probability for this sentence using the machine learning's hidden Markov model. You can get the first order hidden Markov model. You can get this particular value. This is how we have calculated the probability indexes for our data set that we have used for our work. Now the second one, how do we use an exact hidden Markov model process for the computation of the probability? Now, let me tell you that for any machine learning, in case of supervised learning, if you go for the hidden Markov model process, so there's a good example out here. Like if you are having the various word tags, like DET means determiner, ADG adjective, NN proper noun, NNS singular noun. So if you're having these nouns, the arrow shows that the precedence of occurrence of an adjective immediately after determiner is 0.2. The precedence, the likelihood of occurring of NNS immediately after an adjective, singular noun immediately after an adjective is 0.3. The probability of occurrence of a proper noun immediately after a determiner is 0.5. This is what you can see. And the probability of the proper noun holding the values like cat and bet is 0.1. So this is basically a hidden Markov model representation for unstructured text information, textual information. Now let us see how do we mathematically compute it. Now, for a hidden Markov model, it is basically a statistical Markov model. We all of us know it. I mean, you people are also genius in this area of machine learning. It's a statistical Markov model in which the system being modeled is assumed to be within the Markov process and with certain amount of unobserved or hidden states. A regular Markov model, the state is directly visible to the observer, and therefore the state transition probabilities are only the parameters. That's why we use the hidden Markov model for it. Now, during the calculation of the hidden Markov model, we use two tables, or in fact, two probability computations. The first one is the transition probability. The second one is the emission probability. Now, let us see how do we mathematically compute for the hidden Markov model the transition probabilities and the emission probabilities in case of natural language processing. You might have used it for your data processing models also at your end. But in case of natural language processing, the transition probability is the one-step transition probability is the transition probability of transitioning from one state to the other via only a single step. What is the emission probability? The output probability of an observation from that particular state where you are holding on. And that is calculated via this process. I'll be showing you the process as fast as possible. Let us say we are having an example out here. How do we calculate this hidden Markov model's emission as well as transition probabilities?
Banerjee sir, please conclude as the next resource person is waiting in queue.
Okay, sir. Okay, fine. So there are some of the computations which I have already shared. Fine, sir. I'm just finishing it here only. If any of the audience has got any sort of queries, they can drop me a mail at any point of time. I'll be replying them wholeheartedly. Thank you, sir. Thank you from my side.
Okay, please share your PPT also so that we can
sure, sir. I'll be just mailing it to you, sir.
Okay, please. Now I would like to call Dr. Khan, sir, to propose vote of thanks.
Thank you so much.
Dr. Khan. Dr. Khan, are you there? Dr. Khan, are you there?
Yes, yes.
Please propose a vote of thanks.
Thanks, Pawan sir. Thanks to our subject expert, Dr. Partha Sarthi Banerjee, for this marvelous lecture based on machine learning based approaches to convert unstructured text into structured languages. It was a very knowledgeable lecture. The content of this lecture was nicely discussed and presented. Here's some learning from this lecture, that we have learned about the differences between structured, unstructured, quasi-structured, and semi-structured languages. A few case studies regarding Google Assistant, Alexa, and Apple series was discussed. And most of the interesting thing of this lecture was that they have discussed the chatbots and its feasibility with respect to the Indian perspective. And it's a very research oriented topic. So we have to do a lot of work on these chatbots. And also experts have discussed uh, Anil information extraction using SQL interface. And this algorithm was discussed with various its results and its classifications, its various models like Engram and hidden Markov model. So it was a very nice lecture. Thanks, Professor Partha Sarthi Banerjee, sir.
Thank you so much, sir. Thank you so much.
Thank you,
Thank
Dr.
you.
Khan. Thank you, Khan, sir.
Okay, sir. Thank you.
Okay, Lovial, sir, are you there? Lovial, sir. Yeah, good morning, sir. Please unmute yourself. Lovial, sir. Am I audible, sir? But your voice is not coming, sir. Okay, dear participants.
Also, your voice is clear, but we can't hear Dr. Lovial, sir.
Okay, we will see.
There is some.
Yeah. Let me again. Lovial, sir, please unmute yourself, first of all. Yes. Do you have headphone or earphone, sir? Lovial, sir? Please use it if you have, because we are not able to hear anything from your side. Okay, dear participant, it's our pleasure that Professor Dayakrishnan Lovial from the School of Computer and System Sciences, Jawaharlal Nehru University, has joined us as the resource person for today's session. He's a great scholar, and we are fortunate enough to have Dr. Lovial with us in this workshop. So I would like to request the coordinator of this workshop, Dr. Neeraj Kumar Rathore, sir, to introduce Dr. D.K. Lovial, sir. Dr. Neeraj.
Thank you very much. I'm Dr. Neeraj Kumar Rathore, the coordinator of this workshop from IGNTU Amarkantak. Today we have very eminent faculty of the JNU, Dr. D.K. Lovial, sir. I just want to introduce him. He's the one of the eminent professor from JNU in School of Computers and System Sciences. He has done his BTech in 1998 from Lucknow University, and he has done MTech and PhD in 1996 and 1991 from the GNU respectively. He has a very large, vast experience in the teaching. Near about 35 plus years in this field he is working, and his teaching and research experience in the networking field, machine learning, and the NLP. He is already supervised more than hundreds of scholars in MTech and PhD, and he already taken many projects from the government organization like DST, METI, and AICT, starting from 15 lakhs to the crore. and he already published many papers in different reputed journals, more than, because if we are going to be specific, 144 papers in the journals, and conferences in 87 paper in the conferences. He already given his expert talk, more than 100 expert talk in different organization and industry. He already acquired many positions in the JNU, like he was a dean of computer science, and he was director of IQSC. He was a warden and licensing officer. Like this, he got acquired many positions in JNU, and he organized many conferences as well. And he is a member of CSI, ITT, IEEE, ACM, like this. So it's our privileges that today we have a Dr. Professor Robial sir. So I hope you will enjoy his lecture. Thank you very much, sir. Thank you. Over to you, Pawan sir.
Okay, thank you, Dr. Neeraj, for the nice introduction. Lobiel, sir, you can. Okay, your voice is not coming. You just sign out and sign in again, sir. Okay, actually, there is some technical issue. He will join very soon. Okay. Dear participant, please have some patience. Dr. Lobiel is joining again. Please don't leave the session. You will have a very good lecture over. Okay.
No issues, sir. No issues.
Yeah, sir. You are quite audible, sir.
No, fine. So that's why they joined.
Okay. Thank you, sir. Thank you. Okay, you can share your screen, sir, on clicking on share button. कभी कोई दिक्कत हो तो कोई
Still, sir is not audible. Sir, still you are not audible, sir.
Sir, use headphone if you have.
Headphone
Headphone.
एक है उसका.
Sir,
Now-
yes,
now-
it is coming. It is coming, sir.
Coming?
Yeah. Please speak loudly. It is coming. And share your screen, sir.
Okay, that's fine.
Sometime.
Oh, audible and my screen is visible?
Yeah. Please start
Yes, sir.
slideshow, sir.
Yes. Visible. The voice is not clear. It is breakable during the lecture.
I'll go to the next room, right? change my room.
Okay. I think some network issue in his room, so he's changing his room.
Just wait. Let me आ रहा है.
No, sir, your voice is not clear, sir. Mm. So it's not audible, sir.
Sir, just insert again your headphone. Now? Yes, it is clear now. Okay, please start your lecture, sir. It is clear.
I think it may also be a problem in between. I don't know.
You may turn off your video, sir, so that
Video?
we could have the better voice.
Just
You
a minute.
you should stop your video.
No. Okay. Maybe some loose connection. This is the problem.
मैं
Connect.
lose तो है
हाँ,
ना,
हाँ, yes, sir. Whenever
Yeah,
you
yeah.
touch your
I
headphone, ना,
use it daily, but I don't know with WebEx ही problem. बाकी तो मैं रोज ही इसको use करता हूँ.
जी. Just start your lecture, sir.
Just 1 minute. WebEx यूज नहीं करते हैं जनरली ना, तो ये दिक्कत आती है.
Sir.
स्क्रीन नहीं आ रहा, मैं वो देख रहा हूँ ना. आवाज अब तो साफ है ना?
हाँ, साफ है. आप उस माइक को थोड़ा अपने पास रखिएगा तो और अच्छी आवाज आएगी.
ठीक है, माइक मेरे पास ही रहेगा.
हाँ, अब अच्छी आवाज आ रही है सर. आप इसको ऐसे ही रखिएगा थोड़ा पास. जी.
अच्छा, मैं 1 मिनट अपना वीडियो ऑफ करना चाह रहा हूँ. वो
जी. ये स्टॉप वीडियो का ऑप्शन है सर नीचे. आप उसको स्टॉप कर सकते हैं.
ये वेबएक्स फुल नहीं हो रहा ना उसमें.
आपने एक्चुअली इसको डाउन कर दिया है अपने पीपीटी को.
हाँ, वही
दोबारा से शेयर कर दीजिए. जी.
एक मिनट है. ये व्यू फुल व्यू कहाँ से होगा ये?
आप ना सर स्टॉप करके फिर से शेयर कर दीजिए.
मैं करना तो वही चाह रहा हूँ. 1 मिनट है. अब आ रही?
Please start your lecture, sir, and full size screen, na? Yes. Now it is good, sir.
Okay. Now let me start, right? ऑडियो ठीक है? हेलो?
Everything is good, sir. Please start.
Okay. Anyway, thank you for nice introduction. Sorry for these technical difficulties, and I think there have been a good lecture going on. I'll continue from there, and I don't know how much overlap I will have. But let me be very clear that this lecture will be more of an informative than carrying more details of anything. Therefore, I will divide this lecture into two parts. One is that I'll give little background what natural language processing is in my own way. And then I'll talk about how various techniques of machine learning can be applied, which will largely cover. I will not go as I have written here in the slides. These are points basically which will be covered. That's the idea here.
Sir, your voice is breakable. Means sir, it is not audible, sir. Sir, you are not audible, sir.
Voice is not coming, sir. Please reinsert your headphone again.
Hello.
Sir, it is coming now.
ये प्रॉब्लम क्या है? फिर इतनी बार रीइंसर्ट कैसे करेंगे इसको?
अच्छा सर, इसको अब बिना उसके भी अगर हेडफोन के चल जा रहा है तो अब it is coming now. It is coming now.
It is with the headphone.
Yeah.
Coming now?
Yeah, it is good, sir. It is quite clear.
Okay.
तो माइक को अपने मुंह के पास रखेंगे तब थोड़ा आवाज क्लियर आता है. एक्चुअली दूर होता है तो फिर वो ब्रेक हो जाता है.
Hello.
Sir.
It is clear or not?
It is clear, sir. Please start.
तो अभी तो मैं पकड़ा नहीं हूँ. It's mic is all right. What I was talking about is broadly I'll cover little bit of NLP and then machine learning application to NLP, where basically the deep learning and CNN RNN and are used where they are used in the machine learning. That is what the whole idea is. Still not audible?
Yes, sir.
सुनाई दे रहा है?
Yes, sir.
So let me see what natural language processing is. So build up half part of the lecture will be on. I'll not go by the traditional way that it is taught, and then I'll go the application of machine learning. So basically, what NLP is the application of you apply computational methods, the models and extract information from the human language. That means how the human language can be modeled and how the human language information can be extracted. That is what by applying computational methods. That is what NLP is defined. Now, the language may be in the written form, or it is a symbolic representation of a spoken or gesture. Or that means I can have a sign language, I can have a speech. It may not have a script. Many of the languages do not have script today, but the language may have a script that it is a written form that is called text. It is a spoken form that is only speech. It may have both. It may be a sign language where I have a gesture or gesture, whatever you call it. Now, that's what, if I take a written language and then try to apply computational models, that is what is called a text analytics. That is what you have been hearing the word. And if I apply it to the spoken or the speech, then it's called a speech analytics. Then third, if I apply this to a sign language, if you are be hearing something with the dumb and deaf in the news channels, they move their hands and then fingers and then tell about the news. That's kind of a sign language. And then if I deal with sign language, then it can be called a sign language analytics. So these are different kind of analytics which is being done in natural language processing. Now, if you'd be surprised, around 7,000 human languages exist today, currently. That is one. And then you'll be surprised only top 10% or 10 languages cover the 46% of the world population. That means 10 languages are there which is spoken by 46% of the people around the world. And out of 7,000, and remaining is 56. So that means, and you'll be surprised that English language is around 1,70,000 words only. So the vocabulary of a language is limited that way. It's at 1,70,000. And that too is, we use only 10,000 words are commonly used in day-to-day. So if you look at the total scenario, and we get confused that, oh, there are so many words and so many things, how can you remember? Languages, English has 1,70,000 and use only 10,000 day-to-day work. So you don't need to have a big vocabulary that way. And if you look at this chart, what you see is that the top 10 language, Chinese is the most spoken because it's a big population. Then second is Spanish because it is spoken in the Latin America. Then English, and if you look at Hindi comes at a fourth, and Arabic fifth, and this last one is Luhanda, that is Punjabi. Western Punjabi is called Luhanda also. So Punjabi is, so if you look at Hindi, Bangla, and Punjabi are three Indian languages which find space in the 10 most spoken languages. Now, and one of the beauty of this natural language is the language we speak is that the shorter words are used most. Of English karte is, the, a, all these words are mostly used. So that means the shorter words are reused again and again. And the advantage of this is, but their meaning is resolved through the context. If they are using repeatedly or being reused again and again, then in the different contexts, they may carry different meanings. So the context is very important. That is what probably the previous lecture also was covering something about context when we talk of Markov models. So that means the context is very, very important. And the advantage of using shorter words more and more is that it reduces your burden. That means you don't need to recall a large vocabulary. So number of words is reduced. Also that your brain is free for doing less other. That's advantage. How to resolve this point may be easier for you. Now,
Lovial sir, your voice is not coming now.
now,
Yes sir, yes sir.
अब मुझे इसको निकालते रहना पड़ेगा और लगाते रहना पड़ेगा. Is what it seems.
इसको सर आउट करके ही रखिए.
Out के नहीं चलेगा शायद.
अच्छा, वॉइस कम आ रही है फिर.
Something पता नहीं. बाकी दिन तो ठीक चलता है ये. When I use this Zoom or Microsoft, वहाँ सही चलता है.
नहीं अच्छा वॉइस आ रहा है सर. प्लीज कंटिन्यू सर.
Maybe with the WebEx some setting. Of natural language processing as to process sarcasm. अगर कोई आपको कोई व्यंग कर रहा है तो it may be more difficult to identify the sarcasm, the irony, the metaphors, and the humor. That's where the difficulty comes more. I quickly go through this part so that we can spend more time on it. So the ambiguity exists at what sense level? Like say, one word has more than one sense. Any of you are a Hindi speaker? How many of Pawan are the Hindi speakers?
Because we have some faculty from abroad also. So
That because some examples are good examples from Hindi than English.
you can speak, sir. You can speak if.
I'm saying. I can take some examples from Hindi, they are better recognized at times. So, I said the word sense, if those Hindi speakers said, Ram ne Mohan ko kaam par jota, or Mohan ne बैलू को हल पर जोता. If you look at this word jotna, काम पर जोतना and खेत पर जोतना have a different meaning altogether, sense. So this is a very good example which comes from Hindi, and similar examples can be from English. Being a native speaker of Hindi, we find better examples in Hindi. That's the issue. So that means the jotna word has different sense in the different contexts. That is when the ambiguity exists. The काम पर जोतना had not same sense as the खेत पर जोतना, बैलू को. Both had altogether different sense of the word jotna. Then the different grammatical structures carry different meanings. I said I saw a man on the hill with the telescope, and the ambiguity comes because of the structure, whether the man was with the telescope or the hill was with the telescope. It's difficult to find out for the computer. As a human, you can find out. That's the structure itself. Because you go from one syntax to another. Overall, what we are saying is we need computational methods that can deal with the ambiguity. That's what the whole processing is. Therefore, if you look at the language models, with two parallels I've drawn, if I take a text, I have to have a, what I do is I have to find out the characteristics of the language which are grouped into different categories. That is what we are saying. That means there's a model where I need to do morphology, how the words are formed. I'll not go in details of that. And then you have a lexical ambiguity. You divide a sentence into tokens. Then you have a syntax grammar of a language. Then you have the semantics. That means how the semantics has to be identified. I'll explain. Then you have a discourse. Then you have pragmatics. That is what you go with the text. If you go with the speech, you have acoustics, you have phonetics, you have phonemes, you have phonemics, and you have projects. These are all aspects which have to be dealt in the language processing. Whether you apply machine learning, you apply some other techniques. Now, if you look at that, morphology is the shape and internal structure of word. If you take a word, go coach like that, and now become plural. And lexical means you divide into segmentation text in a meaningful unit. That means if I have a sentence, I can divide a sentence into words which carries the meaning. And then the syntax, as I said, the rules and principles apply to make phrases and sentences. You cannot make a sentence by adding any word in any order. There has to be order. So many text techniques which you apply may not cover that order. That's what the important part. Then the semantics comes where context that provides meaning within a sentence. Given a sentence, can you find the meaning of the sentence from the meaning of the words in the sentence? Right? If I say, I eat mango, that means I eat and mango. If I take meaning of every word, I eat and mango, then you find the meaning of the sentence. But if I talk about idiom, probably the idiom will not give the meaning of the sentence will not be the meaning of the idiom, right? That's one. And then you have a discourse. Discourse means it is a group of sentences where the conversations and relationship that exist among the sentences. Because in a discourse, in a paragraph, one sentence is connected with the other sentence, then the next sentence. So it has a coherence in a paragraph. How to cover that? That is called discourse analysis. So you need a different techniques for that. And you have pragmatics. Many times, even if you connect the discourse in a speaker, which is not carried in the sentence, that has to be that is outside the sentence. Now, say for example, if I ask you, you go out, and then I say, you go out, please go out. What? Please go out. Go. So that means if I speak louder, my intention is that trying to look you go out, please go out.
Sir, voice issue is there?
Now, hello.
Sir, now it is coming.
ये बार-बार निकाल के लगाना पड़ता है। Anyway, and ये जैसे नहीं आएगा तो बता देना, I'll do that again. और क्या करना?
Okay, it is coming, sir. I don't know what is the issue, but it is the first time, sir, we are facing such issue.
ये पहली बार फेस कर रहा हूँ।
जी, जी।
मेरा सेटिंग में गड़बड़ हो गया।
कोई इशू नहीं है, सर।
So right, so that means pragmatics means certain information is not part of the sentence, it comes from outside the sentence. It's from the real world context. How to cover that information to get the right sense of a sentence. So it may be intention of a speaker, it may be the information coming from the surrounding. That becomes more challenging as far as NLP is concerned. So this is what the speech part. Today's lecture, I will not cover the speech part, but still, let me quickly go to this slide. Acoustics deals with the representation of the sound. That means signals, the how to represent the signals. And then phonetics is converting those signals into the pattern, sound pattern. And then phonology is that pattern which makes a minimum meaningful unit in a language, sound, speech language. Prosodics concerned with the tone and stress and pitch. That means if you look at in a railway station, when an announcement is made through the speech synthesis, it doesn't look like a natural language, right? जैसे हम बोलते हैं ऐसा नहीं लगता because it is generated by artificially, so it doesn't give that human flavor. So processing, if you look at what you do is the work becomes, I do stemming and lemmatization. Stemming is how the different forms of a word are made. Works becomes from work. Work is made from work. Workers is from work. But lemmatization says workers is made from worker. That means category, the derivational. That means from one category to another category is given in the lemmatization. That means what I'm saying is in the first stemming, you say that it simply says that the word is consisting of only alphabets or characters. But lemmatization say no, it's not only characters, but at times they are one form is converted to other form. That noun is becoming verb, verb is becoming noun. That sense is also taken care of lemmatization. I'll not. Sorry. The lexical representation takes you towards dividing into tokens. Like lecture is interesting. If I say previous lecture, not so that means lecture is one token, is another token, interesting is another token. So that has to be done in the lexical representation. One of the key issue in NLP is the stop words. Stop words are those words which does not carry much meaning or almost insignificant in carrying the meaning of a sentence, and but they are quite often, like each, a. If I say, I gave a lecture, I gave lecture, good enough. Grammatically, they not carry, but I gave a lecture or I gave lecture, it carries the meaning what I want to say. So A does not contribute much to the meaning of this sentence. Like the, is, all these are called stop words. If you remove in a sentence all these stop words, then the remaining in a text will be reduced, and therefore the processing can be done faster. So such estimate is given that if you look at the Shakespeare's complete work, it consists of 8,84,000 tokens. That's what somebody has done a work. And out of 8,84,000 tokens used in the Shakespeare's work, complete work, there are 100 tokens are repeatedly used, and they cover more than half of the text. That means more than 4,42,000 tokens are consisting of only 100 tokens. Keep that in mind. So that 100 remaining 4 lakh, if I say 50%, there are 100 tokens, and then there are 4,42,000 tokens are different. So it becomes almost half plus 100 tokens. So then your processing time will be reduced. That's what it is. This is what the previous speaker talked about, the Engram model used for lexical representation. And that you have heard, that the sense of the next word will depend on the meaning of the previous word. You can go to the n previous word, that is what Engram is, 2 previous word, 2 gram, bigram, so and so forth, by computing the probability. That I will not talk. And a document can be represented in terms of a document term matrix. That means if I take my columns as document and the row as the word coming in all document, then I say that whether some word is coming in document A, B, C, D, then I can fill those cells. That is what I can make a matrix, and that can contain the frequency of a term occurring in a document. This can be one. That is what my bag of word is. Second, each cell can contain the TF-ID, that is called term frequency, and inverse document frequency. That means term frequency means how many times a term is occurring in the document out of the total terms, that is term frequency, and inverse document frequency, that means how many times the inverse of the document term coming in a document out of total inverse of.
Sir, voice gone again, sir. Please reinsert it again.
Okay,
Sir, yes, sir. Yes, sir.
ठीक है.
जी, sir.
आ रही है?
सर, आ रही है.
हेलो.
आपकी वॉइस आ रही है सर, अच्छे से आ रही है.
So you can find out the part of speech like noun, adverb, adjective. That is what. So in English, 9 are the most accepted part of speech. I may be in a given sentence, I may be every word, I'll try to find out the part of speech for that. Some languages can have even more than 1,000 part of speech. हम तो 9 ही noun, adjective, adverb, pronoun यही सब जानते हैं article. But some languages, I don't know even those languages, but the literature says can have more than 1,000 POS part of speech. And I can have a rule-based approach. I can have a statistical approach where you talk of Markov model or Engram model. They are all statistical approaches. And we can have dependency parsing. Dependency parsing is rather than making a parse tree, what you to find out links between different words. Dependence, which words depends on which word. If you make a link that way, that is called dependency parsing. Then there is chunking also. Chunking is it's called shallow parsing. And why it is called shallow parsing? Because I will not see a sentence as consisting of words, but I say sentence consisting of phrases, group of words. If I group words and then make sentence that I said each group of word is a chunk. And then I do my parsing. That is called chunking or shallow parsing. That means rather than doing full parsing, consequent parsing, I am doing only a group-based parsing. This term anybody can go in detail, but then you have semantic relations where you say you have synonyms, antonyms, and hyponymy, and so on and so forth. Also, you have a name entity recognition. Like say, for example, you have to, a word have to be identified in a phrase, which may be a person, location, date, time, quantity. I said that Washington is good. Are you talking of Washington DC as a city, or you are talking of Washington, George Washington, the first president of America? How do you identify that Washington? So in a given sentence, the word is referring to a location, to a time, to a person. It's called entity has to be recognized. That is what the semantic representation. And each word is related to other word. That means if I say Ram is cutting fruits with the knife. The knife is an instrument, so the relation between the cutting and the knife is of instrument, where Ram is an agent who is doing the work, the actor, and the object is the what you call vegetable. So these are for relationship. How do I identify it? In a verb and how the verb is related with the next? That is what calls how to right? Or even you can see that we have semantic labeling. Right? Roles can be subject, object, and so on and so forth. But still semantic relation, like agent, and location, different semantic roles. I'll quickly finish this. Then in a discourse, you may be measuring the structure and dependence of sentence within a discourse. Then how the sentences in a the words in a discourse, different sentences are related. That is co-reference, substitution, ellipsis, conjunction, reiteration, collocation. That means if I say Ram goes to school, he eats lunch there, then he refers to Ram. In a discourse, two sentences that you are trying to say that Ram is, he is as a reference with the Ram. Sometimes we substitute that, what do you eat? I eat mango. Mango is substituted, what is substituted with the mango? Ellipses, certain parts are missing, we remove. Conjunctions. Collocation means, हम हिंदी बोलते चाय वाय पी ली आपने, like that. So these are collocations, means two words come together. And reiteration means we repeatedly use a word again and again. And then we refer to the synonyms used, so we say that this is the same word repeated again. And coherence is you try to find out the semantic meaning in the phrase by using the real world knowledge. As I said, where you say pragmatics could be used. Then you have anaphora and cataphora is the how a noun is related to the pronoun in a discourse. That means Noun comes, then pronoun comes. That is called anaphora. Pronoun comes first, noun comes after. That is called cataphora. So I'll not go in that detail. Important part in before I go to the machine learning approach. Important part here is now in machine language you need to how to represent the words, and this representation is called a word embedding. Embedding that we make a vector space model, and every word can be seen as a vector, right? If I make a two-dimensional this, and then I say each word is a vector, and or each document, say each document is a vector, because I said each column will be using a term, a word, and how many times this word come is in document. If each column is a document one, document two, document three, if I take a first row, it's a word each. So what is how many times is coming in the first document? It's coming in the second document. It's coming in the third document. So this becomes, if I end document, the first word I can say, for example, is represented as a vector with n dimensions because they're n documents, right? So it can be represented as a vector space model. But there is a curse of dimensionality. That means many of the dimensions in this can have a zero value. Some of the terms may not come there. And that means I have a very large matrix because I have thousands of words in hundreds of documents. I have a 1,000 cross 100 matrix. And large of the space is zero. So that is what the curse of dimensionality is. I have a sparse matrix. So that sparse matrix has to be converted into a dense. That's number one. Which can I remove those which are zero values? That's one. Second, of the word vector model or word embedding is the basic principle is that the words which are coming closer are semantically closer in meaning. They have a semantic proximity.
सर वॉइस नहीं आ रहा है नोबेल सर वॉइस नहीं आ रहा है
अब
सर आ रहा है आ रहा है
ओके, आप मुझे बताते रहिए जब ऐसा होगा तो।
जी सर
Now, text classification refers to given document or given n number of documents, they may be classified in different. That means the document relates to tourism, it relates to health, it relates to a sorry, something else. So given a set of documents, you try to categorize them. How do you do that? That can be done by identifying the text within the document. How do we do that? So that is why we have to have a machine learning approach for classification of documents, but that will also require some of the NLP techniques. So this is one. So in addition to this text classification is the core of most of the NLP applications, which we talk about. It includes information retrieval, spam detection, sentiment analysis. Right? Whether some आजकल इतना ट्विटर आता है and you try to say whether this is a positive tweet or negative tweet or neutral tweet. They're politically very highly polarized. So how do I identify the sentiments of a tweet? So given the text, I'll analyze that. I may apply certain machine learning techniques for that. Normal techniques of classification, you apply SBM, you apply something else. I will not go in those techniques because we have studied maybe a lot of techniques of machine learning. So I just spam detection. Even there's something. How do you do that? Either you have a clustering technique or you have a classification. So is your information retrieval. It is given, you have to retrieve the answer of the query. How do you do that? Unless you try to get the meaning of a query, you may not be able to find out the relevant document. You have to find out the relevant document, and from the relevant document, you have to find out relevant information. 2 steps. How do I do classification that whether document is relevant or not? One level of classification where machine learning can be applied. Second level of classification is even if I find out a relevant document is relevant for you, what is not relevant. Not that everything within a relevant document is relevant for you. So again, you apply certain classification to find out which text within a document is relevant for you and which text is not relevant for you. So therefore, what happens is in a text classification problem, we can apply a supervised machine learning approach. We do. So you need a document representation first, either vector space model. Then you need to apply feature selection that, sorry, select certain important features from that document. Apply machine learning classifier. Whether you apply SBM, a linear regression, a logistic regression, and anything method you apply. Also, you need to have some kind of a evaluation of a classifier. How to evaluate the performance of a classifier, that is equally important. NLP, in language processing, when you are doing text classification, you can apply these machine learning techniques, but you also must have a knowledge of the natural language processing. That's what is important. So what do you do? So you have a given a set of documents, which I call label documents. And documents which are labeled documents. The first step is to construct a representation. How do you do that? The common is called a bag of word, which I said the vector is a bag of word. That means every document has a bag of word. Right? There are words. Then you say that whether word 1 occurs in all, which document occurs in which document. That is what a vector is. Then word 2 in which, word 3 in which. But some of the word may not be occurring there. That is not part of your vocabulary. That will also happen. Then we call them out of vocabulary word. Then whether that has to be added or not, and how to deal with the words which are not in my vocabulary. That is another issue. But the Engram frequency also is one of the methods of bag of words, or TF-IDF I talked about another. So what is your set of a labeled document is is called X1, Y1, X2, Y2, Xn, Y. What is your X1? X1 is a vector representing a word, and Y1 is its output. That's what we call Y1 is a label. So you have a label set of documents, vector, right? So that means what you are defining is that set can be defined in terms of vectors along with their output value labels. That's how you can represent your documents if you are applying a machine learning. So this itself is a big task. So what you need is you need to convert a given document in a vector space model. So that means you need to have tools available with you if you are doing Python, which can convert a given document into a set of vectors. That's first task in doing NLP, applying machine learning, using machine learning. First task is convert text into vector space. Done that.
सर वॉइस चला गया फिर से.
आया?
हाँ सर आ रहा है.
आप भी स्लो है.
जी जी.
अब आ गया?
हाँ हाँ आ गया, लेकिन थोड़ा कम आवाज आ रहा है. आ रहा है.
अब
जी जी ठीक है सर, ठीक है.
so what do you? Then you have an annotated means where the labels are not given. Then you predict the labels. That's what the classification is. And the most common or popular algorithms which are applied for classification is K-nearest-neighbor, Bayesian tree, Bayes, logistic regression. These 5 are the most common machine learning algorithms used for text classification. That's why I said this lecture will be more of an informative than really going deep into any technique. So this is what people have been using in text classification using machine learning. Now, but that is not sufficient. A useful technique which people are applying is convolution neural network, CNN. Why CNN is useful for text classification is captures the temporal and hierarchical features in a variable length. Keep that in mind. A sentence in a given text are of variable length. Every sentence will not have a same length. That is very common. But when you make a vector space model, in a vector space model representation, you are making it every sentence is of equal length. That is what you assume. Because where the words are not contained, you assume value 0. But that is where the problem occurs with the previous algorithms which talked about 5, decision tree, Bayes, naive Bayes, because that we are using only fixed length words and it can take more time. Advantage with the CNN is the convolutional neural network is that it is able to take variable length. Second is language structures are hierarchical. If you look, R tree is a hierarchical tree. So therefore, the features will also have a hierarchical. Time relationship is equally important. Whether it happened today, it happened past, whether it is past tense, present tense. So these aspects can be captured by the CNN. That is one. And word or character embedding is generally the first layer in this case. Now, one of the important part is generally we use word embedding or word space we are making is for words. Can I make a vector space for characters? Right? Given a word, I take words in the columns and characters in the row, 26 characters, Maya, then you fill up these space. Huge matrix. And so do a character embedding in a sense, 26 characters, and if you take the entire sentence, then you can say that characters are part of this sentence. That is called character embedding. You can make a vector space model for a given sentence. And this can be given as an input to the CNN. Right? And then CNN can capture that, number one. And further, deep CNNs are considered to be more because they capture the complex features of all natural language processing. That is where people are working on. So I said convolutional network, neural network, and deep CNNs are important as far as text classification is concerned. That is what the current research is going on. Then also now RNN, recurrent neural networks, are considered to be the most useful for natural language processing than even CNN. And you have a deep RNN as well. Why? Because recurrent neural networks are able to capture the sequences. Because because you might have heard the lectures for CNN, RNN in the machine books of earlier. I did not make my slides on those. I'll use that, hoping. That means what in a recurrent neural network happens. Every time step, memory of previous sequence is contained. That means the time step n is depending on time step n minus 1, n minus 2. That means in a word, if I give a sentence, first word is given input to the second, right? And third, the history is being used by the RNN, which is important because in a sentence, the context is important. If you have heard this HMM, where you said the Engram model, the probability of this word n depends on n minus 1, n minus 2. That is where the RNN are very useful to extend Engram models. Right? So that is why I said that the sequence encodes the word embedding at each time step. That's what RNN considered to be more important for NLP applications. Once the entire sequence is encoded in a sentence, the last hidden state is used to predict the class. That's advantage of RNN. That means if the nth word is is used and contains the history of n minus 1, that means the context of the entire sequence is there. So you predict the class, your classification will be better. That's what it is. Which class this sentence belongs to if you are doing classification. And another important is RNN is trained using BPTP, that is back propagation through time. And back propagation is very, very important in neural network. The RNN, that is an important. I'm only throwing the term here. I cannot go in detail for the time limit, and which you can go. I'll give you a book. And then what is the weights are learned.
Sir, voice.
आगे
Sir, आगे.
learn sequentially weight the words. That means the weight of the first word is learned, weight of the second word, the weight of the third word. Third is we learn the weight. That's very important. Important application of NLP where machine learning is used highly. Generally, sentiment analysis, what we have been doing is have been applying fuzzy logic and maybe other logic side, where a sentiment can be a favorable, positive, unfavorable, negative, and neutral. Or you may be still fuzzified by saying that degree of favorableness इतना अच्छा है, बहुत अच्छा है, very good, good, quite good, extremely good. Important is you find out subjectivity and objectivity of the sentiment. It's given a sentence. Can I find out the sentiment of this sentence is objective, subjective? Like say, for example, you can have an opinion about something or you can have an emotion about something. If you look at your opinion, opinions are always subjective. Right? And objectivity, the emotion has objectivity. You may be happy, you may be sad. Objective. Now, in a sentence, whether it is an opinion sentiment or it is an emotional sentiment, you can classify into category. Again, you can use classification techniques. And based on that, then you can say whether this is subjective and objective. A piece of text given to you, you can find out the subjectivity and objective. That means if I have more than one sentence, I'll put the score of every sentence and finally add up the score. Which has more score can be classified in some, and I have a threshold. This is useful in detecting fake news. And that is where the machine learning techniques are applied. Find the fake news in case of a Facebook and social media. Therefore, the classification is important. And three things I said: balance, That means what is positive, negative. Arousal, intensity, what is the degree? Then your dominance. This one emotion may dominate other emotion. And then also in the sentiment analysis, CNN framework people have tried and found out that it is very effective in class, right? Because you can consider more and more features and complex features. That is where the CNN will be useful in that, right? The reason is it may be capturing a lot of context of a previous sentence and is trying to find out. But in a sequence, if you find the past context as well as the future context, RNN can identify the past as well as the future context of a sentence and give you the total meaning. And therefore, and they also have dual LSTM, long short-term memory-based neural network. It's found to be very good for finding sentiment matching. Dual means दो LSTM use करेंगे, that is what will dual. I'm just throwing these ideas, but if anybody is interested, can take on. I'll give a very good reference book. Entailment is another aspect of natural language. That means, can I find a logical conclusion from a given truth? Then I can find some logical conclusion. That means, when I say A is married to B, it logically concludes to B is also married to A. Right? I say A is husband of B implies that B is wife of A. So when I given a natural language sentences, can I infer a leading truth from the given truth? That's called an entailment. And there have been people have done work and they have used parse trees to find out that and then use SVM and logistic regression analysis for that. Probably people have not yet tried CNN and other things. That's what entailment remains an open research topic. And it needs to work on based neural network for entailment. Area people have not worked much.
Sir, some voices is there again. Lobby also is there. There is some voice issue again.
अगर आ गया ठीक हो गया
जी जी जी
जाता है और ठीक हो जाता है
जी 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 सर
ओके
Sir, please try to complete it soon, sir, because we are running time. We are running late a little bit.
ओके जस्ट मैं कंप्लीट ही
जी Okay, sir.
ठीक है ना
Sir, please.
या आई डू 5 मिनट
Yeah.
so that is one area and okay I'll finish and the techniques used is called LSA and this but important part is I'll go these normal techniques I'll see how clear
Clear, sir, clear.
another important machine learning approach used is CNN for topic modeling because coherent I talked about when I talked of discourse I talk of coherent that means how the referencing and ellipses between two sentences can be taken care of that is called your discourse CNN is considered very important as far as coherent and effective interpretation of a topic model. That is what I have not given the references. A lot of work has been done. And the context of the document is captured well by the CNN. That's also important. is we have topic vectors. That means what I say is different references and different topics. Words, I make matrix of that. I have a matrix of a document and words, and I merge them together. That is called a combined document vector and topic vector. If I use them together, it gives a very effective, useful. Then I use CNN as the input. I give both. Then it gives a very good topic representation, and then I can apply CNN here to find out the good results of a topic model. I'll quickly skip this. The important is machine translation, and where the recurrent RNN are very highly used, and one of the important part of this is to use language from sentence from one language and convert it to another one. The important is the encoder and decoder based analysis is very, very important. But it's developed by Google translation system based on the encoder decoder techniques, which I call transformer at times, where your RNN are used for translation. So if you're using translation with Indian language or other languages, use RNN for translation between two languages. Skip this slide quickly. So machine translation is a very, very good example. And BLUE, bilingual evaluation under study, is a very good metrics developed for evaluation of these systems. Question answering system, CNN can be used. If automatic text summarization based and based, and quickly and the libraries used for this work is NLTK is a very, very important tool, which is by Stanford library, which is open source, are used for text analytics. Then you have Spark Sci is an open NLP library for post tagging NAR. GenSim library for open back-based model convert, so you can use GenSim library. And all this can be combined with the Python. You have a Keras for learning flow for machine learning. You can have SCI kit learn, which gives you a lot of algorithm, machine learning algorithm, and Pandas library for data service. Combine all these tools, then you can develop very good machine learning-based approach systems for NLP using Python. And of course, matplot everybody knows. And with this, I'll conclude. I'll give these slides, not a problem. So neural machine translation is one of the most significant application of NLP tool. So that's the hot area. Lot of work still needs to be done for Indian language. And huge efforts are still required for generation of corpora for Indian. Until unless you have a good corpus, you cannot develop empty system and you cannot apply machine learning. And still we don't have a digital corpora for many of the Indian language. And reinforcement learning is another area can be useful for NLP applications. The reason is it temporal dependency and non-differential optimization. The gradient fails, therefore the reinforcement learning works well. It can be used for text summarization. And you have heard something like video storytelling. Means if given a video, can I identify the caption of that? That is also an NLP area. And then, yes, this is the book which you can follow. The Deep Learning for NLP and Speech Recognition by Uday Kamath, Springer 2019. Latest book is a very good reference if you really want to learn few things about machine learning for NLP. That's the idea, is to give an information, not to go in detail of anything. With this, I'll thank you. Thank you very much.
Okay, thank you so much, sir. Dear participant, do you have any query you can ask to sir? Participant, do you have any kind of queries? Okay, you can put me. Okay, so there is a query. Which NLP model is the most accurate? Lovial, sir, there is a query. Which? Yeah, quite audible. Your voice is not coming again, sir.
आगे?
Yes, sir. आ गई.
If you are doing machine translation, deep neural net or recurrent neural networks are very good for machine translation application. Right?
Okay. जी. Any more queries, participant? Okay. So it was a very good and nice lecture, sir. It is my privilege and honor to propose a vote of thanks to you, sir. On the behalf of the organizing committee, Department of Computer Science, IGNTU Amarkantak, I propose a vote of thanks to Dr. D. Kilobial from the Department of Computer Science, Jawaharlal Nehru University. Sir has delivered a very fruitful and very great lecture on machine learning applications for the NLP. Sir have discussed natural language processing, but how it is basically being used, how machine learning use NLP. Sir have discussed semantic discourses, pragmatics, text classifications, and what are the machine learning approaches behind them. Sir have discussed about the text classification using RNN and RNN using BPTT also. Sir have discussed about entailment, topic modeling, and how it is being used by CNN, and machine translation, what is fluency or faithfulness, etc. And sir have also discussed about bilingual evaluation, understood it as BLEU. And sir have talked different software used for the library, for example, NLTK, SPACY, Genesis library, and so on. Sir, it was a very great lecture, and although we know that that was some little bit voice issues, but we are able to understand whatever you are telling to our participants. Sir, on the behalf of all the participants who are attending on WebEx, I welcome you. I thank you, sir, for this great session, sir. It was our pleasure that you have joined our workshop, sir. Thank you. Thank you so much. Thank you, sir. And please share your PPT so that we can share with our participants, sir. And I have mailed you, sir, one honorarium receipt, sir. Please sign it and send to me, sir. Please, sir. Thank you so much, sir. Have a nice day ahead, sir. Thank you. Thank you, sir. Thank you. Participants, we will meet at 1:30 sharp. And I have signed the attendance link already. And the time was, attendance for the time was 12:30 last. But now I am sending again, but time is over. We will meet at 1:30 sharp. Okay.